Okay, let's get this kicked off. So hello everyone and welcome. Thank you for joining us today for the Spectrum and Users, What You Need to Know About the Path to Fixed LTE webinar presented by Telrad Networks. My name is Dori Iran of Eye-Opening Marketing and I'll be the moderator for today's event. We'd like to hear from you today, so ask questions and share comments. Use the question and answer panel on the right side of your GoToWebinar player to share at any time during the webinar. We will have a couple of poll questions, as Tom mentioned, during the webinar. Those will pop right up on your screen. We'll give you a few seconds to answer each and share the results. We'll also have time for questions at the end. Today's presenter is Tom Gruba, VP of Telrad Marketing, who has over 30 years of experience in the telecommunications market. Also presenting today is Steve Coran of the firm Lerman Center. Steve is the chairman of the firm's broadband practice group and serves on its management committee. His practice focuses on the representation of broadband providers and equipment and technology companies, serving policy, compliance, and licensing needs. He also actively represents a trade association before the FCC, Congress, and other federal agencies. Also joining us today is Nick Dewar, Vice President of Systems Engineering and Business Development for Telrad Networks. While not presenting today, he has a wealth of LTE knowledge and will help to answer any product or technical questions that arise. We're proud to have them all here today, and without further ado, I'll turn the presentation over to Tom Gruba.
Thank you very much, Dori, and thank you all of you for joining us today. And to give you an overview of what we're going to cover, we're going to talk about what's changing in the marketplace, why managed spectrum is essential to success these days, what's the latest with CBRS and spectrum. So thank Steve very much for coming today. And then we're going to talk about the affordability, because I know a lot of people have questions on, well, you've got LTE, but is it affordable? So there are big, significant game changers, and those have to deal with users and what they're doing, and what we can expect them to do. And then things that have happened that you may not have 20 years ago thought would ever happen. That was unlicensed spectrum being used by tier 1 mobile operators. CBRS, right, is coming, and it's about to hit the scene. It's a big influencer because it adds 100 megahertz of spectrum, which at 5 bits per hertz is 500 megabits per second of capacity out there. So that's very good. LTE products in the fixed wireless market, we'll talk about what the pros and cons or differences are relative to mobile, and why we think they're very effective in that marketplace. And we've got a lot of proof points there. And then people ask questions now about 5G, which of course is a great thing, but it can be confusing because people want to know, should I stop and wait for 5G or not? So we'll talk about that. Before I do that, and before I get into what's happening with users, Dori, we have I'm going to say survey. It's not survey. It's help me with it, Dori.
It's the first poll, yeah.
Poll, thank you. The first poll.
So yeah, I'll go ahead and launch that right now. So the question is, where are you in the process of evaluating fixed LTE for your network? Are you determining the business case, investigating LTE technology, evaluating LTE vendors, looking to try it, or some other?
This is very helpful when you respond to the things like the poll, because it gives us insight into what are the top of mind issues that you're grappling with or looking to answer. So thank you very much for all of you that are voting. And even if you're not an operator yourself, you can go ahead and vote on something that you think would be relevant from your perspective.
Okay, I'm going to give this another few seconds. And I'm going to go ahead and close that poll now. So, sorry, here I'm sharing the results. So we have determining the business case at 23%, investigating LTE technology at 8%, evaluating LTE vendors at 23%, looking to try at 15%, and other at 31%.
Very good. So for a lot of you, it's understanding that business case and then evaluating the vendors. So that shows where people are in their process. So let's move the conversation to what's happening with users. If you look on the left-hand side of this slide, you see that today there are lots of options for streaming video. And in 2010, 4.5% of households cut the cord, right? Cut the cable cord. And in 2016, that had risen to 22%, representing 27 million households. So that's quite extensive, and we think the trend's continuing. Also of note is that you talk about SD video, HD video, and of course 4K video. And when you look at what Amazon and Netflix publish and recommend, they say it's somewhere between 15 and 25 megabits per second per stream. So we have that as a benchmark for what's going on. And you look and understand that there are only 21% of census blocks, or sorry, there are 21% of census blocks with no access to 25 megabit per second or more. On the right-hand side, we talk about what's happening in the household. Multiple streams in a household are common. And so when two things of note, number one, if you're selling a product, your service, and multiple streams are being used, the more capacity is being consumed. The second thing is that people coming from cable think about streaming video just like they do cable. No one's told them any differently. So if you walk into a home of someone that's got streaming video, you may find 2 or 3 televisions on streaming data simultaneously. So that's going to have a direct impact on a fixed wireless operator's business. And so let's take a look at that. If you look at the table here, if you were running one stream in a home and the package you sold them is 15 megabits per second, if the average usage per home is 2.5 megabits per second and your subscription spot is $50, well, you're looking at 2.5 megabits being a cost per home of 2.5%. But think about it if you've got multiple streams. You're not getting any more revenue, but they're consuming more of your sector capacity. Let's take that to another example. Look at the second row, which is 2 streams. Even if you're selling a package at 25 megabits, the consumption for 2 streams is 5 megabits or more. These assume SD or HD streams, not even considering 4K. So if you understand the underlying problem here, you've got the average consumption per household on the rise, and the concern is additional consumption with no additional revenue. So this creates a couple problems. Number one, how do you get the users to pay more? If you talk about your service as a best effort, most users don't understand what best effort is. Number two, if you talk about a service like 15 megabits per second, which is what I get in my home, people don't understand, well, why should I have 15? Should I have 25? Should I have 50? In fact, a friend of mine very excitedly told me he had 192 megabits per second service, and I said, well, great. What can you do with 192 that I can't do with 15? And he fell silent. And he's a tech guy. So you look at it, and users, most of us don't understand what we're buying or why we're buying it. However, if you're going to go compete in an area that's offering cable where they're offering 100 megabits per second and you're a wireless provider, it's easy to understand that you're going to have a difficult time competing head-to-head with a 100 megabit service. But what you can compete on is educating users and talk about something they understand. How many streams do I want to have simultaneously running in my home? And you show them a price point, you give them a good service. That's what they're really after. So you don't have to go head-to-head with the cable company on a 100 meg service. You can offer it by the streams and types of services that you want to support. Number two, the second problem is how do you quickly and easily increase network capacity to keep up with that consumption? So here are the mechanisms for keeping up with demand. And what you want to look at is buying equipment. So the decision you're making is not just for solving a problem today, it's what are you going to do long term. So number one, there's a thing called a software-defined radio, which simply means I can increase the feature functionality of that radio while it's in the field on a tower without rolling a truck. The second important thing is working with vendors that have a capacity roadmap that's part of a plan. If you look at the next bullet, I talk about a flexible radio or access point. In LTE, it's called an eNode B, but for just the sake of simplicity, we'll call it the radio. So you see 4T by 4R, that's 4 transmit, 4 receive. Those are the number of the antennas that are in the radio. You're comparing what Telrad has, which is a 4x4 radio, to say a 2x2 radio. And what 4x4 means is you've got increased flexibility of what you can do in terms of capacity, non-line of sight, and other characteristics that will give you more life for that particular radio once you've mounted on the tower. The second bullet there, wideband radio. What a wideband radio means is how much spectrum can that radio use at one time. Now, LTE is a standards-based technology, and so if you look at it, 5 bits per hertz, it's actually 5.5 bits per hertz, but let's just make it easy. 5 bits per hertz is what any LTE radio will give you. It doesn't matter which provider, which vendor, it's a standard, therefore you can expect to get 5 bits per hertz. So if I have 40 megahertz of spectrum, 5 times 40 is 200 megabits per second is the maximum capacity in that configuration for that radio. So the wideband radio means if I can address 40 megahertz of spectrum, it's much better than a radio that can address 20. The second thing, and the third bullet, is the tunability. Tunable across the band. The example I give my kids is when we talk about the car radio, I say what the tunability means is if you've got in the car and you turn on the FM radio, you're going to want to be able to tune from the low end of the band at 87 point whatever all the way up to 107.9. You would never buy a radio that only tuned part of the band, would you? They of course said no. So for all of you, the characteristics of a radio that are going to be important as you make a product selection is making sure that that radio can handle not only what the spectrum will allow today, but what it may allow in the future. And the reason that's important is, of course, CBRS. We'll talk about that in a little bit. The third bullet, selecting the right spectrum to reduce interference problems. So interference, quite simply, robs the system of capacity. So the more interference you have, the less capacity you have. It doesn't matter what the radio has written on the box. It's simply a matter of the physics of how this all works on something we call signal to noise ratio. The last bullet is if you're planning, plan for additional capacity that you're going to need in the system. Therefore, you're going to be looking at acquiring additional chunks of spectrum, and that's where your growth plans come in, looking at can I utilize 20 meg, 40 meg, or 60 megahertz of spectrum. So from a Telrad perspective, having a 4x4 radio and making sure that operators have plenty of capacity, here's an example of 3 key features that are important to the future of operators as they deploy networks. Number 1, carrier aggregation. That simply means if I have 2 separate chunks of channels of spectrum, I can concatenate them together and make it look like one. Why do you want to do that? Because if I've got 2 20s, I bring them together, that makes 40. 40 times 5 is the 200 megabit per second. If I had a 20 times 5, I could do 100 megabits per second. So you've doubled your speed by using this function called carrier aggregation. And it is a software feature and a software update when you deploy a Telrad radio. The second feature here is called multi-user MIMO. Through great technology, what this means is I'm increasing the efficiency of the radio. So we talked about the 5 bits per hertz as part of the standard, but with the feature in the standard called multi-user MIMO, you're able to go from 5 bits per hertz to 10 at a theoretical maximum. Now, just word of note, no one ever gets theoretical maximum, so just know you're going to get something like 40% more capacity, 50% capacity, depending on your individual conditions. So the way it works is it actually transmits out of both pair of antenna using the same channel. So in other words, I can serve more users out of that sector with the same spectrum that I have. The third and final is called dual sector. So let's say that you're facing one direction, you're facing north, you're serving customers there, and you want to deploy to the east or south or to the west. You can actually, the dual sector means I can have another sector out of that same radio. And if you think about it, I might be using 2 of those antennas, 2x2, heading north, and the other 2 antennas facing south. And therefore, I'm able to cover twice the area with one radio, which is a very cost-effective use of your capital. So today's challenge with spectrum, if a lot of you have been operators or are operators using unlicensed spectrum, you know this very, very important component, that there's more companies requiring spectrum today than ever before. you've seen it and witnessed it because the noise floor starts to rise. 20 years ago, we talked about 2.4 gigahertz as the spectrum of choice. It's a lower band, has better transmission characteristics, but no one talks about 2.4 anymore because Wi-Fi has come through, the noise floor rises, and it makes it very difficult to achieve capacity limits. So now people are using 5 gigahertz, but the same problem is coming. Why is that? When we look at it, mobile operators are using unlicensed spectrum for part of their data transmission, and those are coming through things that you may have read about called LTEU, that's LTE unlicensed, or LTE LAA, licensed assisted access. What licensed assisted access means is they're using part of their licensed band to set up the call, and then they're using the unlicensed portion as the payload. Multifier is another one, another technology, all of these using 5 gigahertz. So the bottom line, the takeaway, is that as 5 gigahertz noise floor rises, it reduces capacity and it interjects risk into your business model, right, into your business plan. And some people say, yeah, but that's in the urban areas, that's not rural, right? Rural doesn't necessarily mean low population density. If you take places in central Illinois, they're called rural communities, but they're towns of 35,000 or 40,000 or 25,000, which are certainly big enough to be markets for the major operators. So when we talk about conditions where the noise would be the lowest is when you're out in farming communities where your density of your population is extremely low. So just important to understand where you are, where you plan to operate, and what that environment looks like. So reducing the business risk is all about making sure that you've got the right radio performing at the right level. And you say, well, what's that look like if I'm using unlicensed? You know, you hear a lot of promises of increasing capacity because they've gone from 64 QAM, which is a modulation scheme, which simply means the number of bits that it can deliver, and you go from 64 to 256 QAM. So when I do that, the part that no one talks about, or the non-technical don't talk about, is you have to have a very clean, low noise floor environment, or you don't get that extra speed that you paid a lot of money for. So let me give you a couple examples. If you're driving a car in the flatlands and you're heading to Colorado, as you hit the mountains, you're typically going to have to downshift. So you've been in 5th gear, and now you're going to have to downshift to 4th, 3rd, or 2nd. You still get up the mountain, you just don't get up there as quickly. Another way of talking about it is if you go to a party and you're the first people at the party, I can have a conversation across the room. I can talk very fast. Everyone hears me, not a problem. But as that party fills up, you've got to get closer and closer to that person. This is the same thing that a radio has to do. You've got to get closer and closer to the transmitter to be able to hear. And a lot of times you end up making very simple messages like, do you want another drink? Or come here. So you have to actually slow down and speak up. So that just says there's no guaranteed capacity in an unlicensed area. Okay, that's the risk. So that's why licensed spectrum is becoming a business imperative. You need to first determine, is my service area at risk for rising noise using 5 gigahertz? And the action that you should take is actually to investigate 2.5 gigahertz opportunities in your area, or the 365 opportunity to get a license, and do that before someone else acquires it. So those are the big takeaways and things you should be doing right now if you're looking at deploying LTE. So at this point, I'm going to bring in Steve Curran, who's going to talk about what's happening, what's the latest, and because Chris is right there in Washington, understanding what's going on in all of these. So with that, I'll turn it over to Steve Curran.
Well, thanks, Tom, and appreciate Telrad inviting me to be a part of these regular educational webinars. Let me talk first about 2.5 gigahertz spectrum. Sprint has the vast majority of this spectrum around the country and is deploying LTE. It's probably their 3rd or 4th try to actually deploy commercially successful services and business on that band. But there is some there are some stray cats out there and other spectrum out there, although Sprint has recently increased its interest in acquiring spectrum it doesn't have. So as the slide says here, this is provides predictable capacity for educational broadband service. There's a 35-mile circle, that's the radius, not the diameter, in which you have protection on a given license. For the commercial channels, which is called broadband radio service, they're generally area-wide licenses that cover multiple counties. And within those borders, you are protected from interference from others. Benefits is you can offer SLAs to business customers with confidence. There's more than 190 megahertz of spectrum here altogether. If you're lucky enough to get it all in one place, which you probably won't be. And one of the things that's important to understand is the FCC is initiating a process that's long overdue to see if they can find ways to make this spectrum a little bit more usable. So one way is maybe get rid of some of the educational restrictions, and for future licensing, allow commercial entities to apply for white space EBS spectrum. That's just one of the proposals, or two of the proposals that are on the table. And as of today, the comment deadline is July 9th of 2018, so just a little more than 30 days away. It's possible that date could get extended, but suffice to say there's a lot of interest, and my client, the Wireless Internet Service Providers Association, WISPA, will be active participants in that proceeding and hope to create new opportunities for future licensing for commercial purposes. In the 3 gigahertz citizens broadband radio service that Tom referred to earlier, this is 150 megahertz total. 100 megahertz of that is new, that sits at 3.55 to 3.65 gigahertz, right below the existing 3.65 to 3.7 band. So that's how you get your 150. Some of this spectrum is going to be auctioned in 10 megahertz pieces. That's 70 megahertz of the new 100, with the remaining 30 being sort of a license by rule, which is like unlicensed with a registration requirement, with governance by something called a spectrum access system that determines priority access, incumbent access, priority access, and then this third tier of general authorized access, and also will facilitate coordination among those in the lower GAA, general authorized access tier. So there's a rulemaking that's also underway at the FCC that's been going on for too long, and industry is trying to come together to resolve some differences that might change the size of the areas and the term of the license for those areas that will be auctioned off. The bigger the area, the longer a term, the more expensive the licenses will be, and the more likely they are to cover larger areas that don't correspond to where a lot of wireless ISPs and Internet of Things and venues might want to serve. In other words, why should you be forced to get a long-term lease on a shopping mall when you just want a short-term lease for a pretzel shop inside the mall? So 365 licenses do exist, but there are no new ones. So if you wanted to acquire one and get kind of a head start on using this to eventually use a significant portion of the bigger 150 megahertz band, there are licenses that you may be able to find on the secondary market to kind of get you going before the band opens up for GAA use, probably by the end of 2018. We're not likely to see auctions on the auction part of the band until 2019 or 2020, given the other auctions the FCC has teed up between now and then. There's also proposals to open up the band between 3.7 and 4.2 gigahertz, which is currently licensed for C-band and is underutilized but overprotected. So a group that WISPA is affiliated with, called the Broadband Access Coalition, that Telrad is also a member of, has applied to the FCC to open up that band for coordinated point-to-multipoint use, shared with existing C-band satellites. The mobile industry obviously wants to use this for another 5G band, so the FCC is at its July meeting, not too far away, going to be adopting a notice of proposed rulemaking, which will kind of set in motion what potential rules might be. We should see a draft of that released to the public on June 21. And so if you look at this to go from 3.55 all the way up to 4.2, and with NTIA also thinking that bands below 3.55 could be commercially available with not too much disruption to the existing Navy operations there, you could be looking at a pretty wide swath of significant midband spectrum, all of which is either LTE ready now or should be fairly, in the fairly near future. One shameless plug: if you're headed out to Mountain Connect in Vail next week, you can get a deeper dive on this with myself and other panelists. So please make plans if you're headed out there to sit in on that session, which is next Tuesday at 10 at the Hotel Talisa Vail. So that's what I got on this slide. Tom?
Great, thank you very much, Steve. And if people have questions, then don't be shy about writing them in, and Dory will get to them here.
Yep, we actually do have a question. When will your CBRS equipment be ready to deploy?
We're actually, anything you buy now is deployable, and it is CBRS compatible. Nick, anything to add?
Yeah. So to answer the question, today it's all certified under Part 90. It's the same equipment. Part 90 being the existing 365 rules. Part 96 rules. We're in device certification right now. So we're pending really SAS certification and the commercialization of the band before you can actually use it commercially. In the meantime, you'd have to operate under the Part 90 with the existing 50 megahertz or with STA or experimental license. In the
Very good. So
to 3650.
Great. So the key thing, I think, Nick, is people can buy equipment today, and we're going through the certification process. We know our stuff's going to work there. We've done field trials with SAS, and so your investment is protected, correct?
That's correct, yes.
Okay. So I think that's front and center.
There is
Dory?
one more question regarding a previous slide. Can you mix carrier aggregation and MU-MIMO on the same sector?
No, you cannot. Not on this platform. They're both 4x4 features that have different implementations. So with carrier aggregation and the future feature 256 QAM on a 40 megahertz channel, you would be somewhere in the range of 270 meg. That's with 40 megahertz. However, with MU-MIMO and only 20 megahertz, you'd be in the range of about 220 to 230 meg. So it really depends on the peak rate requirements and so forth, of which model is most suited.
Very good. Thank you, Nick. Any other questions on that, Dory?
Yep. Does the CBRS go further in terms of distance from the tower and trees and so on?
That's a great question, Nick. Go ahead and give people a little bit of a NORAD background here.
The EIRP, the max power limits, are a little bit higher in CBRS. So from that sense, from an RF standpoint, it's more than double the power output with a minimum of 4 dB additional transmit power permitted. So yes, there would be some level of improved propagation, but simply due to the additional gain.
Okay, and one last question. Does the carrier aggregation do 15 plus 5 megahertz to make the 20?
No, it does not. The channels, they need to be of the same bandwidth.
Very good. Anything else, Dory?
That's it for right now. There is one question that I oftentimes get: will the slides be available for download? So we do, after the conclusion of the webinar, we will send you an email, a follow-up email with the link to the presentation.
Yep, very good.
Oh wait, one more question just came in. Is CBRS better than 3.5? Does it have more capacity?
Read that one more time.
Is CBRS better than 3.5? Does it have more capacity?
So let's, the slide I just turned to, let's look at that. So CBRS stands for Citizens Band Radio Service, and it is a portion of the spectrum that goes from 355, as you see here, all the way up to 3.7. So 365 it goes from the 355 to 365, so it's the or to 365 to 3700, excuse me. And so that's the 50 megahertz. And so we're simply with CBRS adding 100 megahertz of spectrum for a total of 100 megahertz. So it is not going to impact performance. It simply gives you additional bandwidth to work with, which will impact your service offering because you'll have potentially more spectrum to work with. Okay, so if that answered the question, then this slide, and I want to make sure that Steve's on as we talk about this. I've talked to some prospects who were saying, we're going to wait for CBRS. And waiting is akin to going up to the starting line and waiting for your competitor to come up and start the race at the exact same time. So in my opinion, you don't want to wait. What you want to be able to do is what I have in the second bullet. If you currently do not have a 365 license, you can go acquire one. You can come to Telrad, and we've got people that have approached us on wanting to sell their license. What we hear is we've seen them on eBay from anywhere from $5,000 to $6,000. That would be a very good investment because it would get you up and running, and you're going to start deploying before other people deploy in that area. So, in my opinion, no reason to wait. The wait period has to do with what's going to happen for the PAL licenses, and the PAL license is an auction, as Steve indicated, which will happen in the future, which will give you additional spectrum to the GAA portion, which is the general authorized access, which basically means anyone can use it. And it is a managed band, which means the SAS system that Steve talked about, it's a monitoring system to understand and coordinate spectrum use between different operators. So the picture gives you who's using spectrum where, but the important part is what I've circled in green there that says, hey, if you get that 365 license, you're really looking at operating between 365 and 3700, and the GAA band increases from there, as well as the opportunity to get a PAL license. And as Steve said, GAA will be at least 80 megahertz of the 150 with 70 up for auction. If people don't buy it, Steve, correct me if I'm wrong, but it becomes GAA usable if no one's purchased it.
Right, it's also GAA usable if no one has deployed. So it has a use it or share it opportunistic component to it for those that want to deploy under those conditions.
Very good. Dory, I'm going to ask if there's any questions around this.
Yep, there are a couple that came up. If you currently have a 3.65 license, can you register new base stations?
Answer to the question is yes, you can register new base stations, and but they won't be given grandfathered treatment during this transition period that ends in 2020, but you can continue to deploy as if they're regular old Part 90 Subpart Z licenses, and many people are doing that. Many people are doing that based on their acquisition of LTE equipment that's software upgradable to operate in the entire 150 megahertz.
Okay, another question is, with CBRS, will I be able to get more customers? I'm topping out at around 30 per sector right now.
So what Nick will tell you is the more spectrum that you have, the more capacity you have. So depending on how much spectrum you're currently using, adding to that will give you the ability to add more customers. Either that, or you end up with using a feature like multi-user MIMO, where you'll be able to increase users given that it uses 4 antennas to do that.
Okay, we've got a hefty question here, so bear with me. Under CBRS Part 96, end user devices are limited to 23 dBm EIRP. How will ODUs from Part 90 now be converted to Part 96 rules if such devices need to be CBSDs due to output EIRP and require SAS approval before making any transmission?
That's a good question. There are 3 types, as it sounds like you've done your homework. So the end user device category A and category B. So category B has an EIRP limitation of 47 dBm per 10 megahertz channel. So our subscriber units within the Telrad solution would be certified and usable as a category B. Our BreezeView network management platform actually acts as a domain proxy. So on behalf of that subscriber, the domain proxy will request grants and so forth from the SAS and maintain a grant process for that specific subscriber to transmit.
Okay, we're good to continue, Tom.
Okay, very good. Thank you very much. Those are great questions, folks. So keep at it. That's why we're here. When people talk about, will licensed spectrum kill my business case? I want to share something that came out of a consulting firm called Wireless 2020. And when I talked to them, I said, so what is the going rate for spectrum, and how do I compare it between mobile and fixed? If you look at the upper left-hand corner, 2.5 gigahertz, if you were looking at the way that the spectrum is evaluated, it's dollars, right? Dollar per megahertz pop. Pop is population. So let's take population out of it for now, because that's really just a multiplier. So it's really how much you're paying per dollar per megahertz. So in mobile, it's $1. So if I wanted 20 megahertz of spectrum, it would be $20. But if I'm in a fixed environment, notice that the price is 35 cents. Same spectrum, but for a fixed application, it's much less. Why? Because the value of mobile and what people do in terms of auctions, it's much more valuable because of the size of the market. In a fixed environment, 35 cents is probably the top end. We have had numerous conversations with operators who've been able to acquire 2.5 gigahertz spectrum in markets that are not described as high value mobile markets, and therefore they'll be paying 20 cents, sub 20 cents into the teens. So each case is different, which is why I implore you to go have the conversation with Select Spectrum or others in the marketplace that understand this and can get you an actual realistic quote for what your review would be. Now, if you go down to the next line, it's the CBRS line, you see it says 30 cents. Well, the GAA has no cost. So GAA is no cost spectrum. However, when you look at the 30 cents, that would be for PAL license auctions. This is Wireless 2020 expectation of what the top end value would be for that spectrum. And you look at it and you say, well, 30 cents, that's awfully close to 35 cents. Why is there that 5-cent difference? That's because 2.5 gigahertz has a little bit better propagation characteristics than 3.5. So they, as consultants, figured out that there's probably a premium for 2.5 versus 3.5. Again, you won't know what the spectrum is worth in your particular area until those auctions come out. But if I'm doing a business case, I can plug numbers in, see the impact, get some idea of where do I need to be when I go out and bid. So let's talk a bit about reducing business risk in the CBRS band. And so number one, we talked about the tunable radio. And the second thing is we talked about the 40 megahertz wideband head, so the service area of the radio itself. And it is tunable across 300 megahertz with the Telrad radio. And so I have a picture down below that really says, if I'm operating between 355 and the top end of 37, a Telrad radio is going to easily cover that entire spectrum. And what that means, if I were going to use a feature like carrier aggregation, see that I have my one chunk of spectrum, the 10 megahertz carrier on the left, and let's say I was assigned one all the way on the right, a worst case scenario, our radio can handle that. It can aggregate the two, and it would look like 20 megahertz of spectrum. The 20 megahertz times 5 is 100 megabits per second. Okay, so this is really for planning. It's also to understand investment protection, that regardless of what's going to happen there with CBRS, the radio is going to operate effectively across that band. So before I get into fixed LTE, Dory has another poll for us.
Yes, I do. I'm going to go ahead and launch it right now. So what is currently holding you back from making the move to fixed LTE? You're not sure there's a business case, you're acquiring spectrum, you think acquiring spectrum will kill your business case, you don't know which vendor to choose, or you're not sure what value fixed LTE brings to your business.
And thank you for all of you that respond. It really helps us understand what questions people have. We then use that as inputs into future webinars as we talk about changing it up in the second half of this year. and what's on people's minds.
Okay, I'm going to give this a few more seconds. And I'm going to close the poll now. So we have not sure there's a business case at 40%, don't know which vendor to choose at 40%, and not sure the value fixed LTE brings to the business at 20%.
Okay, thank you very much. So let's talk about why fixed LTE, and I think we can answer some of those questions. Number one, from a research project commissioned by WISPA, the association representing wireless ISPs and other operators, they reached out to find out these parameters. What does the average revenue per user look like for operators today? 70% of participants said that they're getting over $40 a month. If you want to say, well, look, I want to make $50 to $60 a month, 23% of those of the 69% were getting that 23%. And if you say, well, look, I really want to do more than that, $60 a month, 27% of operators are getting more than $60 a month. So very healthy numbers. Churn is minimal. Churn, most people are in the range of less than 1%. Okay, there's some that are less than 5%. Realize that churn can have a couple things outside of your control. That's whether or not people could have a job. And it could be that maybe there was a competitive offering that came into view. So churn very minimal, very healthy business environment. Subscriber acquisition cost. So when you talk about LTE and people say, is it affordable? I think $400 per sub. If you looked at 300 to 400, 400 to 500, that is in your range of what it would cost. And realize that 200 of that or more is going to be for the outdoor unit, the CPE itself. So LTE is very affordable, not because it's just the price of the equipment, but it's the longevity. So in a lot of cases, wireless ISPs buy equipment and they look at it as something going to be deployed for 3 years, and that's what they write their business case on. But LTE is going to last much longer. I use the term 6 years, which I felt was a conservative number. I've had 1 or 2 of our operators tell us they're actually planning to get 7 or 8 years out of it, which I think great for them. So it's an ROI, return on investment business case using LTE, as opposed to what is the cash out of pocket buying the radios. Growth, when we look at growth here, 57%, over half reported 11% per year or better growth, which is terrific. Obviously, there's a CAF 2 opportunity for those of you that are involved. You already know that because of the deadlines that have come and gone. And then you're looking at whether they're using licensed or unlicensed spectrum. And let me just say now, although there is risk with unlicensed spectrum, Telrad doesn't say don't use unlicensed. It's just understand where you're using it. So many of our operators will actually use both. They'll use licensed plus unlicensed. So we're not saying don't use unlicensed. We're saying it comes down to who am I trying to serve? If it's a business customer, maybe I'm better off using LTE, where I can get a service level agreement in place. So with that, you talk about what are the 10 reasons why LTE makes sense for fixed. So from business generation, for those of you struggling with line of sight issues, so it's a non-line of sight technology, which translates to more share per tower, which reduces your cost per sub overall. The ability to offer service level agreements, again, to those business customers is very important, because those business customers rely on it, and when they don't have the service, they're unhappy, so they're, of course, willing to pay more for a service level agreement. For those of you looking at exiting the business, you're going to have more value, because when we talk to the finance people, they understand that LTE is a standards-based technology and therefore has residual value. The equipment has residual value when you go to sell, where in most cases, if it's unlicensed, they know it's proprietary, they value that at 0. Loans are easier to come by. We've had a couple of customers tell us that when they were previously trying to talk about technology, they didn't get anywhere. When they said it's the same technology that you have in your pocket with your cell phone, they actually broke through, have that conversation. And of course, LTE, known to be used around the world, is a very scalable architecture. Business protection. So if you look at saying, well, gee, Tommy told us about the video that's occurring and the consumption, how are we going to keep up with that? Realize that the LTE standards 3GPP roadmap is driven by the world's largest mobile operators. It's driven by all operators, but most importantly, those top mobile operators that are really struggling with capacity more than anyone else. LTE, because it's standards-based, you get your choice of manufacturers, you can mix and match. I'm not saying it's a plug and play easy, but it is something that can be done. And then, of course, you end up with the functionality because of the standard that makes it more carrier-grade, reliable, and high-performing. And then in terms of CPE, you get more options on CPE and more manufacturers. So if someone's roadmap is not going the direction you want, you have other alternatives rather being dead-ended into one vendor. And then last, and something that doesn't get talked about an awful lot, but when you look at your talent pool of people that understand LTE, so many people have worked in the industry over the last 11 years that have been trained on LTE. They understand the technology, they understand the EPC, and so your available talent pool of people that understand it number in the thousands, the hundreds of thousands of people. Engineers is what I'm talking about. So if we talk about the ecosystem in CBRS, Steve covered it very well. So it's just that additional 100 megahertz of spectrum. CBRS doles things out in 10 megahertz channels. Remember the rule of thumb of 5.5 bits per hertz. A competing non-LTE solution is going to be using very large channels, and Nick can give you something that he helped me with, which is an understanding of why LTE operates so effectively, because it breaks things down and uses tiny slivers to be effective against interference, where the need in unlicensed radios is to use a very wide channel, which is then susceptible to more noise. It picks up noise from a much wider stance. Anyway, we'll move on there. Importantly, LTE deploys different than other technologies. It starts out as a base minimum by having 2 antennas. That's because they work with reflections to be effective. So wherever that signal bounces off of, they're able to capture it. One antenna misses it, the other one might capture it. And so as a non-line of sight technology, most people in wireless have dealt with line of sight issues. So now you're dealing with a non-line of sight technology, which is different. OFDM-A is the modulation scheme that LTE uses, which is an advancement of OFDM. I point that out because people will hear OFDM, OFDM-A, and they may not know that there's a big difference between the two. LTE is the advancement off of OFDM. And then LTE, like I said, leverages the reflections for non-line of sight. It makes use of multipath, which means that when you're setting it up, you're going to be looking at slightly different parameters than other wireless systems. And so to avoid a bad experience, really take one of our training classes or get set up with one of our starter kits to learn about the technology and what it takes to be successful there. What about 5G?
There is a question.
Yeah.
What is the best antenna for Telrad base stations?
Oh, Nick, I don't know. There's a best probably for situation, but Nick will chime in here.
You know, we tend to default to a 4-sector 65-degree design. We have an attached antenna model within our solution. It's a small footprint form factor that allows the base station to mount in behind the antenna. So from a deployment perspective, certainly that is most optimal. From an antenna type point of view, it's a double dual slant, cross pole -45 +45, and 65-degree 4-sector reuse 2 design. But in terms of design specifics, we'd be happy to review with you in a dedicated session and involving one of my radio network planning engineers.
Terrific. Any other questions, Dory?
That's it for now.
Okay, perfect. So people, the other thing about not waiting for CBRS to be finalized to move forward, people also ask about 5G. So what I have is 2 drawings here. Focus on the drawing on the left for a minute and look up at the top. You'll see in the blue that the 5G prototyping, research, trials, standardization, all of that evolves over time. Now, if you look down below in the green, you see the releases. So 3GPP releases the standards in what they call releases, release 10, release 11. You can see the timeline down below. And currently, the green horizontal line below that is you've gone from LTE to LTE Advanced, and then there's an LTE progression after that where you see it here as B and C. So when those things happen, now look over to the right, because really you look at the green arrows that I put in there that says LTE Advanced Pro. That's what that says, that little text you can't read. So you look in that 27 timeframe where the standards are being written. You see release 14. You see release 15 down below that that's been worked on simultaneously. And that evolution path goes from LTE Advanced Pro on the left all the way over to 5G. So it's happening concurrently. So at every G change, meaning you're going from 2G to 3G, 3G to 4G, 4G to 5G, there's overlap and concurrent standards being written. They do that for the seamless experience. So on the evolution path, all the standards come into play. So in other words, don't wait for 5G. 5G new radio, and there's a lot of confusion. There's 5G. People talk about spectrum for use with 5G, but really for the advancement of speed, the capacity, and the low latency, that deals with the new radio. Those new radios won't be out until probably trialing in late 2019, early 2020. And of course, you've got everyone aggressively stating dates currently, but we'll see what really happens. Just as a summary for goals and challenges, you're looking at, if I want to increase market share per tower, what do? I use non-line of sight and I increase capacity. I want to extend the life of deployed assets. I've got field upgradable and extendable products and a capacity roadmap. So this is just a summary takeaway slide that when you're reviewing what we've talked about today, I just tried to put it into one slide. So why Telrad for LTE? Number one, when you've got the non-line of sight, the higher capacity, the capacity roadmap, you're getting higher market share per tower. That reduces your overall cost. And so you're looking at a very effective solution as you scale. Leveraging capital efficiently. I've got a slide and one or two that talks about the different ways that you can deploy our radios that is much less capital intensive. So what we want you to do is we want you to get out there and win. We understand that if you win, we win. So being able to deploy a radio initially as a 2x2 radio, but growing it to 4x4, adding additional capacity features, having you spend money along the way, pay as you grow, is much less inhibitive to success for everybody than requiring a lot of money right up front. The third is that an important thing that we always should talk about is it's not just about the radio, it's about the entire system and what Telrad can bring to the party. So we'll talk about that here as we go forward. So a very important characteristic is LTE is a layer 3 technology. And so Telrad had to actually write all of the layer 2 software to be able to provide you the features to serve business customers. And as an example, in that second bullet, in the first bullet under there says avoids the requirement for NAT, that's network address translation, or double NAT. It's also, the layer 2 is important for gamers, business and advanced end users, sensitive to latency. So being able to have that layer 2, which is a bridge, just like getting across the river, it passes everything over. It's the same thing here. And then 3GPP doesn't really define static IP. In many cases in deployments, there are opportunities where you need to have a static IP. So as we talk about it, Telrad has developed the entire suite of what you need in terms of layer 2 features. So if you're evaluating all the different vendors, make sure you know that they've got everything that you need to serve business customers who are going to want to eliminate leased lines and do other types of connections between different offices, for example. LTE operators. This is just a small list of our operators that have been successful, continue to be successful, continue to grow and expand their networks, some of whom are competing very effectively with cable companies. And word of note to those of you that are looking at competing with cable companies, the stat I heard was that at any point in time, 10% of homes are looking to get off of cable onto a competitive offering. That's how well loved the cable companies are not. So I promised you a slide in terms of deployment scenarios. the flexibility that Telrad offers, and look at these as two horizontal lines. So the top row and the bottom row. The top row, notice that each of these starts with the word low or lowest. So if I'm looking at my minimal investment, what can I do? The one on the left is I want to get out there, I want to test the market, I want to try this out, I want to see if I can get enough users. This is a very cost-effective way of doing it. Your performance is the same, it's just that you're using a 2x2 radio and able to reach that deployment cost effectively. Go all the way to item number 3. Here's where we talked about that dual sector. And in this case, we also have dual carrier. The dual sector, I could serve 2 areas, as you see, the blue and the green, that are in different spaces with one radio. So you put one radio on the tower, that's much cheaper because you've only got one asset to hang, one lease fee to pay, less to put up. It's just all in all a lower cost situation to get started. The second row, look at the first words, maximum. So each of these, I need maximum non-line of sight penetration because I've got that type of a problem. Here you're going to use the radio in a 4x4 configuration. If you go to number 5, you're looking, I need a maximum peak rate. So again, you're using carrier aggregation here. I'm able to combine 2 channels, 2 20 megahertz channels in this case, and deliver up to 200 megabits per second. And then the third one, number 6, is really using the radio as a multi-user MIMO, where I only have so much capacity. So notice the difference between 5 and 6. 5, I had 2 chunks of 20 megahertz. In number 6, I have 1 chunk of 20 megahertz, but I need to serve more customers. How do I do it? I use multi-user MIMO. And the bottom line where I've got it bolded, notice that in all the others, the number of bits per hertz is 5.5. Here it goes up to 10, but realize this is the marketing on the can because that's what the standard says. You won't actually get 10. You'll get better than what you currently have. You will serve more users, but expect to get 40, maybe 50% better. Okay.
Hey, Tom, I've got several questions, if you don't mind.
No.
Okay, so I have trouble reaching people in the first mile from 2 of our sectors. How do you know exactly the tilt to use, especially tilt versus distance?
Honestly, we always recommend using professional tools to do that, and that's a service that we can provide. We can assist with that. We have the clutter data for all of the US and Canada. We have professional radio network planners, and we use the tool known as Mentum Planet. If you have specific coverage polygons that you require, we can tailor the design as such to service the locations for which are priority to you and your business.
Okay. How many base stations are needed for maximum coverage of 360 degrees?
We propose and recommend a 4-sector back-to-back channel reuse design for 360 degrees.
And Nick, that would also give you maximum capacity, right? Because 4 radios is going to give you more capacity than if you covered it with 2 radios and using dual sector.
Yes, absolutely. The 4-sector design would give you the capability to evolve to the 10 bits per hertz with the use of MU-MIMO and so forth. There would be a more economical way of doing it using just 2 base stations in what we call dual sector, meaning 2 ports to sector A and 2 ports to sector B. So 2 base station over 4 sectors.
Okay, if we use dual sector, dual carrier, does it limit TX power to half of radio capacity in each sector?
No, it does not. We would have full power on each port.
Okay, and when is MU-MIMO going to be available?
MU-MIMO is progressing very well. We have some fantastic feedback from the testing that's being done in Israel. I expect we will see this feature in Q4. An added bonus will be 256 QAM will be coming in the same time frame, give or take.
Okay, that's it for now. Tom, go ahead.
Those were fabulous questions. Thank you all very much. Really appreciate those. This picture I've got up is a comprehensive solution. So you see the CPE. This isn't all of our CPE. It's some of the CPE. Note CPE 9000. That's a category 6 device that allows you to do carrier aggregation. So if you want longevity of your CPE on a home or business, you might consider the CPE 9000. Going to the right, one of the things that has been an inhibitor to success for many companies is the fact that they had to buy an evolved packet core. It's part of LTE standard, and it is important because one of the pieces of the cores you'll see at the very bottom is the packet gateway that gets you out to the internet. They're the interfaces for how do you authenticate and how do I bill. So those are all built in. What Telrad's done is we've slivered that up. We've put an EPC into each radio, so you can operate it there, or you can set it as a centralized EPC, or you can operate them in tandem, both together. So there's a lot of flexibility there. And what we've done is we've sliced the licensing up per user to make it more affordable for you to get started in enrolling rather than having a big license to choke on it up front. I'll turn your attention to the right column, which is network management and performance, and then CPE management, which is the middle. What I'll say here is this. Operations of a wireless network is like a leaky bucket if you're not careful. Everybody focuses the attention on what's the upfront cost. No one focuses on, or few focus on, what does it cost to operate a network. These two tools that Nick and his team and the team in Israel have fashioned allow you to manage your network much more cost effectively from a computer in the office and find out what's going on without having to roll a truck. We could do an entire session on these, but just know they're very important in helping you keep your operational costs down. I'm just going to skip over that.
Real quick question, Tom.
Yes.
Which CPE support 256 QAM?
That will require a Category 12 subscriber unit, which will look to be introduced in the future.
Great question. Any more, Dory?
Nope, that's it for now.
Okay, so I really appreciate everybody hanging with us here. I see the numbers have actually gone up, not decreased. So just a couple key points. How do you get started with telco, with Telrad? Number one, you can contact Mike Cook, who's our VP of Sales. He's a fabulous person. He came on board 6 or 8 months ago. He'd love to hear from you. And then he'll get you to the right person in the sales territory. You can also send me a note. I'm happy to work and get people to the right place. And mine is just tom.gruba@telrad.com. The discussions you want to have are, number one, go back and evaluate your spectrum needs. We can have conversations about spectrum and the planning for how that impacts your business case. So the first bullet is really evaluating pricing. Remember that it's a return on investment, not an upfront equipment cost that you want to be doing your modeling on. Those deployment options, so as we talked about, gives you a lot of flexibility for getting started with either less dollars or more effective use of dollars, meaning covering more area for less money. We can do an entire turnkey. So we know that sometimes a new technology, say here it is, but how do I actually get it deployed and implemented and on the air? So we do training sessions. We actually have services portfolio. We can do everything from soup to nuts to make sure that we get there. One of the highest compliments we've received is, you know, when there are problems, Telrad actually cares and comes out and makes sure that we get the problem taken care of. You can spend a day with us at a road show, an industry event, or a meeting. Dory keeps those published on our website, so we'd love to hear from you. If there's not one in your area, send us a note. I'm looking for feedback on where to do the next road show. Buy a starter kit. The starter kit is set up and tailored to you. It is a small investment, but an investment nonetheless. But it is set up, and one of the brilliant things that Nick did is he actually assigns an engineer for that, I believe, 30-day period while you're underway to provide you the support at no additional cost, which is a great way to get started and get the experience. As I mentioned, the Telrad 3-day training, and then also you can talk to some of our other Telrad customers. Webinars, I've been doing these every month with Dory. We'll probably go on hiatus over the summer just because July and August are so heavy with vacations. We'll look to do one in September. If any of you have been on the call and said, really like to learn about this, or can you go in and do an entire presentation on network management, provide us the feedback, and then we'll create one and we'll do one. And then you can see the lineup here, and this is the last thing I'll cover, is that the next big show that we'll be at, the NTCA regional shows in July and August. look at the NTCA website and you'll find out where those are. They're in some great places. And then Wispapalooza in Las Vegas, October 8th through 12th of this year. And then again, we're always looking for additional opportunities to talk to people and have that conversation in real time. With that, I'm going to check with Dory on any additional questions that we might have.
Yeah, so first up, before we get to the last questions that I see here, we're going to launch the last poll. This one is really just to make it easy for you. If you want to be contacted regarding a trial kit, if you're interested in one, mark on here that yes, please contact you to arrange, or you still have questions regarding the technology, or that you're not ready, and this will make it easier for us to get in touch with you quickly and take out one step for you to have to reach out to us. While that is loading and being answered in the meantime, let's get to the final questions. Does the AAA server have to be where the base station is deployed, or can it be remote?
It can definitely be remote.
Yeah, absolutely. AAA would be centralized in most cases, but it does not need to be co-located.
And can the EPC be deployed in a high availability or redundant scenario?
Absolutely.
Absolutely. There's various ways. There's even an embedded EPC that you can have a centralized EPC and have it fail over to an embedded EPC as like a local survivable option.
Okay, great. I think we are done with the questions.
So I want to thank everyone. I especially want to thank Steve and Nick. I'm honored to work with such great talent, and I really appreciate their help and support, because there's so much to know and to learn about LTE and about the spectrum and about the technology that I couldn't do this without them. And of course, thank all of you for being here today. And a special help is Dory is always the person that keeps me rolling on these and make sure I've got everything lined up. So thank you to all of you, and we'll hope to get feedback from you and see you at a roadshow or an event.
Yep, just to add to that, we will be sending out a follow-up email with a link to the presentation, and also we will have a very short survey that we will launch as soon as we end the webinar. We would be very grateful if you completed that to help us improve in the future. On that note, we'll end the webinar today. Thank you so much to everybody and to our presenters. We really appreciate all of your time.
Thanks, everyone.
Thank you.
Thank you.